Hi, welcome everyone. In this series of videos, we are going to learn how to program these ARM7 devices. In this video, we are going to see how to write an assembly language program to multiply two 16-bit numbers. So this will be helpful for microcontroller and embedded system lab for the Department of Computer Science and Engineering. Myself, Muhammad Ali, I am working as an assistant professor at Mysuru Royal Institute of Technology, Mandya. Whenever we start writing any assembly language code, we need to declare this line. That is, first we need to declare an area and we need to give a name for that area and type of that area. So we'll see that is first we need to define an area. So let us take, we have a memory. So in that memory, we are taking some part and making this as a memory area. Right. So we'll give a name for that area as multiply. So we can give any name, but here we are writing a multiplication program. That's why I will give a name multiply. So why this area is used? What we are writing? So we are writing here a code. So code is combination of set of instructions that becomes a code. So for example, we can write any instructions from the ARM7 instruction set. So that's why we have written it as code. Next, what type of memory it is? It is a read-only memory, that is ROM, read-only memory. That's why we'll write read-only memory. Now, here we need to multiply two 16-bit numbers. So first we'll take a 16-bit number to a register called as R1. So let us take as a number 0x1234. So here 0x represents hexadecimal number. So this is 16-bit. You can observe here. So 0b is for binary number. Binary number, what we are writing next to that 0b is a binary number. That is 1 is 0001, 2 is 0010, 3 is 0011 and 4 is 0100. So this is a 16-bit number. So how will will send the data 0x1234 to R1? By using an instruction called as LDR. LDR R1 is equal to 0x1234. This will load a constant value, that is 1234 to R1 register. So similarly, so we'll take one more number, that is 0x2345 in R2 register. So this is also a 16-bit binary number, that is 0b, 0010 is 2, 0011 is 3, 0100 is 4 and 0101 is 5. To load this constant value to our R2 register, we will write an instruction LDR R2, is equal to 0x2345. Now we have taken two values in two registers. So next we'll multiply these two values, that is we'll multiply R1 into R2 and the result will be stored in R3. To do that, we have an instruction, that is MUL R3, R1, R2. So this will multiply R1 and R2 and the result will be stored in R3. So how this multiplication is performed? So we have two values, hexadecimal values 1234 and 2345. So first it will multiply these two values. So we'll go step by step, that is 5 into 4, like that. So we'll get the value 5B04. So how it is? 5 into 4 is 20. 20 is nothing but in hexadecimal 14. So we'll write 4 here and 1 carry on the top of 3. Next is 5 into 3. 5 into 3 is 15, that is F. F plus 1 carry what we had got from the previous multiplication, that is F plus 1 will be 10. So we'll keep 0 and we'll take a carry 1. Now we'll multiply 5 into 2, that is 10. That is equivalent to A in hexadecimal number. But we have got 1 carry in the previous multiplication, that is A plus 1 is equal to B. Similarly, 5 into 1 is 5. That's why we got 5B04. Next, we'll multiply 4 into 4. That is 4 into 4 is 16. We'll get a hexadecimal value as 10. So we'll keep 0 and we'll mark 1 as a carry on the top of 3. Similarly, 4 3s are 12. 12 plus 1 is 13. That is equivalent to D. Similarly, 4 into 2 is 8. We'll directly write as 8. Next, 4 into 1 is 4. We got 48D0. Similarly, we'll multiply for all the numbers and we'll get the answer as 2820404. So after all the multiplications, we'll add these values. 4, we got LSB 4. Next we have 0 plus 0, we'll get 0. Next B plus D plus C will get 24. So that's why we have 4 here and 2 carry. So we'll see in the calculator, that is B plus D plus C. So we have taken the programming mode calculator. So we'll write in hexadecimal number. First is we have B plus D plus C. So we got a number 24. That's why we have a 4 here and 2 is carry. Like this, we will add all the values and we'll get a value 2820404. So we can verify here. We'll multiply hexadecimal number, that is 1 2 3 4 into 2 3 4 5. So we can see here we have a value 2820404. That's what we got the result. So we'll start writing the program. To write any program, we need a KEIL Microvision software. So we'll open this KEIL Microvision software. So it will open the previously worked project. So we'll create a new project. So we'll go on to project. So we'll select new Microvision project. So it will open a new project wizard. So in this, we'll select the same folder what we have selected in our previous program. That is, I have created a folder in desktop called as ABC. So here we'll create this project and I will give a name as multiply for this project. We'll save this and it will ask for to select a target device. Our target device is LPC2148. That is a ARM7 microcontroller. So we'll select this and click on OK. It will ask to start a startup file. So we'll click on No. So we can observe here we have created a target which is having a source group. Now we need to write the program. So we'll select the file and new. We will get a blank window. So we'll save this blank file with a name. So we'll go to file, save, and we'll give a name multiply, and the extension should be .asm. Because we are writing an assembly language program, that's why we need to give .asm as our extension. Then we'll save this file. So now Once we save this file, we need to add this file to our source group. That's why we'll right click on source group and select add existing file to source group. So here we need to select ARM source ASM source file and we'll select this multiply and we'll add this. Once we add, we will close that window. So we can see here in our source group we have added multiply.asm file. So now we'll write the same program what we have seen previously. In any assembly language program, we need to write this directives and this instructions after a tab. And other than these, that is labels are written without any tab. So here we have taken two label, entry and start. So these two are labels just to indicate we are starting the program. These two labels are not written with any space or tab. So other than that, so we have directive as well as instruction that should be written after a tab. So now once we have written the program, we'll save the program by clicking on save. Next, we'll build the program by clicking on this build target icon. So to know the working of how to use this KEIL microvision, so you can see the previous video. So once it is built, it will show that if we have any errors or warnings. So you can see here we don't have any errors and warnings. That's why it is showing 0 errors and 0 warnings. So once we have built our program, so we need to debug this program. So we'll click on this debug start or stop icon. So we'll click on OK. So here we can see that we have a program and in the left side we can see our registers. So we can see all the registers are having a value 0. Now these two arrow marks indicates so we are running this instruction, that is LDR R1, 0x1234 will be run when we click this step button. So these step buttons are used to debug step by step of the instruction. So if I click once, the first instruction, that is R1, is filled with a 16-bit binary value, that is 1234. So you can see here we have a value in R1 0x00001234, that is in 32-bit register R1, so we have a 16-bit value 1234. Other 16 bits are zeros. Next, we'll press once again step icon. So the value 2345 is loaded to a register R2. The next instruction is we'll multiply this R1 and R2 and the result is stored in R3. So we got a value 02820404. So the result we can verify in our calculator, that is we are multiplying 1234 and 2345 in hexadecimal value. We are getting the answer 2820404. The same value we have got here 2820404 in register R3. So this is how we'll write the program and we can multiply two 16-bit numbers and the result is stored in another register R3. So we can change the values. So to change the values, so we need to exit from this debug session. So we'll click on this stop debug session icon and we'll write another number 1234 into 1234 itself. That is, we'll change the values and we'll save the program. Next we'll rebuild the program so that we can check any errors and warnings. Then we'll start debug. So now we'll run this program step by step. That is, first 1 2 3 4 is loaded to R1. Next in R2 also we'll load 1 2 3 4. Now we'll multiply R1 and R2, that is 1 2 3 4 into 1 2 3 4. We'll get the answer 14B5A90 in our R3 register. So if we are multiplying two 16-bit values, so we can get up to 32-bit result. So here we have got this result. So we can write this program to multiply any two 16-bit values and we can save up to 32-bit result in a register. So we'll stop the debug session. So in this way we can write the program to multiply two 16-bit numbers. Thank you.